A truck manufacturer built an engine so unreliable that fleet operators sued the company that made it, while, a few states over, a competing engine from a rival automaker was quietly logging 300,000 miles with nothing but oil changes. Curious. Both trucks came from the same era. Both were sold to the same customers for the same jobs. Only one of them became a warning label in used truck listings for the next 2 decades. An owner-operator in central Indiana bought his truck new in 2004, expecting a decade of hard, reliable work. Frustrated. 18 months later, he was paying for his second engine teardown. By the end of this video, you'll understand exactly which engine earned its reputation as the worst in modern trucking history, and why the villain wasn't a bad idea. Thoughtful. It was a deadline. Forward reference number 1. And there's a number coming up later. The actual dollar figure Ford set aside to deal with this problem. That will change how you see every used Super Duty on a dealer lot. By the mid-2000s, roughly 2.5 million Ford Super Duty trucks were on American roads carrying this engine under the hood. Fleet buyers, tow companies, and independent haulers had all made the same bet. That a new, more powerful diesel would mean fewer repairs, not more. B-roll note: wide shot of a highway lined with diesel pickups towing trailers. The owner-operator from Indiana had financed his truck specifically because of its advertised towing capacity. 325 horsepower, 570 pound-feet of torque, numbers that beat anything Ford had built before. He signed a 5-year loan believing the engine would outlast the payments. Instead, within 2 years, he was pulled off the road for weeks at a time, watching invoices pile up for parts that hadn't even existed in Ford's previous engine. The system responsible wasn't secretive, it was regulatory. New federal emission standards forced every diesel manufacturer to redesign engines almost overnight, adding cooling systems, recirculation valves, and electronic controls that had never been tested at scale in heavy-duty trucks. Ford's urgency to release its new engine quickly meant certain issues emerged early, including injection system glitches tied to software problems that affected emergency vehicles and led to lawsuits. The company wasn't cutting corners maliciously. It was racing a federal deadline with unproven technology, and hundreds of thousands of trucks became the test fleet. Every manufacturer faced the same deadline. That's the part that matters. Chevrolet was under the exact same federal pressure, building its own new diesel platform on the exact same timeline. 2 companies, 1 law, 2 very different engineering decisions about how to survive it. One company added complexity externally, where a technician could reach it with a wrench. The other buried the most failure-prone new component deep inside the engine block itself, where it couldn't be inspected without a full teardown. B-roll note: split diagram comparing external versus internal cooling architecture. That single architectural choice, accessible versus buried, is the seed of everything that follows in this story. But this is only the surface layer. Forward reference number 2. Because one single component, smaller than a laptop, buried deep in the engine block, is responsible for nearly every failure that came after it. To understand what went wrong, you have to go back to the engine this one replaced. Ford's previous diesel had run for 14 years with a reputation for toughness, reliable, simple, proven. B-roll note: archival-style footage of an older Ford diesel engine bay. Then came 2003, new emissions law, new engine platform, built jointly with an outside engine manufacturer under enormous time pressure. The design used an oil cooler buried inside the engine block itself, coolant flowing through narrow internal passages instead of an external radiator. B-roll note: cutaway diagram of a diesel engine block with the internal oil cooler highlighted. It looked efficient on paper. In practice, it clogged, slowly, silently, every truck, eventually. Sediment built up inside the cooler over time, which meant engine oil no longer cooled properly, and coolant flow to the EGR cooler dropped at the same time. A second critical part starved of what it needed, right as the first part failed. One weak point triggered the next. Then came the oil pump. The high-pressure oil pump sat in the valley of the engine and used lower-quality materials, so the internal gears developed stress cracks and eventually shattered, leaving the engine with no oil pressure at all. For the owner-operator in Indiana, that failure came on a Tuesday, hauling a loaded trailer through Ohio. No warning light gave him more than a few minutes. Then came the injectors. The engine relied on high-pressure engine oil, not a separate fuel system, to fire each injector electronically. When the oil pump degraded, the injectors degraded with it. One system's failure became another system's inheritance. No backup, no isolation. Just one long mechanical sentence, and every part of it depended on the part before it. Slow-motion animation of oil flow stopping mid-cylinder. Fleet mechanics who serviced dozens of these trucks began keeping informal checklists, not of what might break, but of what would break, and in what order. But here's what most people get wrong. They assume this was one bad part. It wasn't. It was a chain, cooler, then pump, then injectors, each failure feeding the next, on an engine platform with almost no factory redundancy built in to stop it. Here is where the numbers matter, because this wasn't a story about one unlucky truck. It was an industry-wide financial event. Owners of this engine platform report needing what the aftermarket diesel industry now calls bulletproofing, replacing at least 4 of the engine's main failure-prone components just to make the truck reliable enough for daily work. A full bulletproofing kit, upgraded oil cooler, upgraded EGR cooler, and reinforced head studs typically runs into the thousands of dollars in parts alone, before labor. For an independent owner-operator, that is a bill that competes directly with a truck payment. That's the equivalent of an extra loan the driver never agreed to sign. The initial version of this engine also had glitches in its injection system tied to software problems, which affected emergency vehicles and led to lawsuits against the manufacturer. That is not a footnote. That is a fire department or an ambulance service discovering their new trucks couldn't be trusted to start a shift reliably and taking the manufacturer to court over it. Now compare that to the rival diesel from Chevrolet, built by the same emissions deadline, same regulatory pressure, same era. Its most reliable generation is widely considered the strongest of the modern diesel era, built with fewer emissions components and a stronger fuel system, and paired with a durable 6-speed automatic transmission. Even its weaker generations had contained specific weak points. One generation known mainly for overheating due to restrictive airflow, another for a specific fuel pump failure, rather than the cascading block-level failure chain found in Ford's engine. Here is the counterintuitive turn. Most viewers assume worst engine means the engine with the most complaints online. It doesn't. It means the engine whose failure points multiply each other, where fixing problem 1 exposes problem 2, which exposes problem 3. Ford's early 2000s diesel had exactly that structure. Chevrolet's diesel, even in its weaker years, generally had one identifiable weak point you could isolate, repair, and move past. Cascading failure versus isolated failure. That difference, isolated failure versus cascading failure, is the actual economically measurable gap between these two engines. It's not brand loyalty, it's engineering architecture. Think about what that means for the person actually running the truck. A tow company owner with 6 trucks on this platform isn't looking at one repair bill, he's looking at 6, staggered over a few years, each one arriving without warning, and each one capable of parking a truck for a week or more. For a small fleet, that's not maintenance. That's an unplanned second payroll, paid out to parts suppliers and machine shops instead of drivers. Multiply that single owner's experience across the roughly 2.5 million trucks built on this platform, and you start to see why the aftermarket, bulletproofing industry itself became a multi-million-dollar business. Companies built entirely around correcting a factory design. Meanwhile, the rival Chevrolet diesel followed a different economic path entirely. Its strongest generation is still, today, one of the most sought-after used diesel engines on the market, commanding a genuine price premium specifically because buyers trust its architecture. That's the quiet, unglamorous truth behind resale value. It's rarely about brand loyalty. It's a market pricing and risk that most buyers can't name, but every mechanic can. Forward reference number 2 resolved. That buried oil cooler wasn't a side issue, it was the root of the entire cascade. Forward reference number 3. And that architecture gap is exactly what determines resale value on used truck lots today, which we'll get to next. If you've worked around diesel trucks for any length of time, you've probably felt this without ever hearing it said out loud. Some engines fail because of one bad part, and some engines fail because they were never designed with a margin for error. That instinct was correct. Close-up of a mechanic's hands running a diagnostic scanner on an engine bay. Here's what most buyers still don't realize when they're shopping a used Super Duty from this era. The truck's engine may already have been through a full bulletproofing rebuild, or it may be a ticking clock with the original factory oil cooler still installed. Two visually identical trucks, two completely different financial futures, and almost nothing on the exterior tells you which one you're buying. That single piece of knowledge, checking service records for cooling system upgrades before checking anything else, puts you ahead of most buyers standing on that lot. Most people are still comparing horsepower numbers and paint condition. The ones who understand this engine's actual failure chain are comparing repair invoices instead. Forward reference number 1 resolved, the dollar figure. Ford's warranty and buyback costs tied to this engine platform are widely reported to have run into the hundreds of millions of dollars, a bill the company absorbed, and one every subsequent Super Duty buyer indirectly paid for through pricing and reputation. Forward reference number 3 resolved. That gap in engineering architecture is exactly why, 2 decades later, the Chevrolet diesel from this same era still commands a stronger resale price than the Ford. Buyers are pricing in risk, whether they can articulate it or not. Which brings us to what happens next. Right now, thousands of these engines are still on the road, still being bought and sold, still carrying the same buried oil cooler that started this entire chain of failures 2 decades ago. Every one of them is a countdown clock disguised as a good deal. The buyer who understands that isn't afraid of the truck. He's just no longer willing to buy it blind.